We are Apptastic 4, and I would like to propose our Distributed Systems Semester project. Have you ever been at a sports event looking for a friend? A basic "I'm at left field" at a crowded stadium may not quite be enough. Have you ever considered what would happen if your child wandered off during a field trip and ended up in a place without an internet connection? It would be nice if there were some way for them to locate the rest of the group when it's time to head out. With these situations and others like them in mind, let me now introduce you to Meet Me Now, a mobile application that will serve as a facilitator for locating others. This application will work by allowing a user to send a pop-up message to a friend and guide them to their location by showing an arrow to direct them to the correct spot. Let's take a look at a simple example. Bob would like to locate Alice in a crowded stadium. With current technology, Alice could send a text message to Bob saying, "Where are you?" And Bob could reply with his location. But now let's also say that Bob's location is not so easily describable, and there is a poor network connection in the area. If Alice and Bob are within a reasonable distance from one another, and there are enough wireless devices between them, could these devices cooperatively forward packets amongst each other and lead Bob to Alice's exact location? Leave it to Apptastic 4 to answer that question. A tool such as this one will bypass the need for network providers and "Where are you" texts. With this mobile application, you can send a swift notification or add a message if you like to let someone know your location in order for you to quickly be found in places that have proven to be the most difficult. Using geographic coordinates of each wireless device in close proximity with the users along their path, a continuous chain can be formed to facilitate this cooperative location service. The key features of this application are the fact that it is completely distributed, there's no use of the internet, it will include pop-up notifications, a user-friendly interface, and the coverage size will increase as more users get on board. We have scoped out our project to include the following: routing, failure handling, bootstrap configuration, and peer-to-peer with no need for a central server. This mobile application's communication will consist of a mixture of multicasting and routing protocols using direct Wi-Fi as a communication channel. We will use name location pairs to represent different nodes or users in the network. It is vital that the nodes all have the same understanding of the network to facilitate coordination between them. For the routing, we plan to use a geo-routing algorithm. If each node can determine its own location and the user is aware of the approximate location of the destination, then a message can be routed to the destination without prior route discovery. Greedy forwarding and face routing can be used to find the destination step by step. This will be essential for looking up members and sending requests within the application. We have also considered some of the challenges that may come along with the implementation of this idea. These challenges include routing, as in how do we distribute route information and handle frequent routing updates? How do we handle hop-to-hop delays? When do we time out, and how frequent should we transmit? In terms of mobility, how do we establish, maintain, and update routing information with fast-moving devices? While also considering loss, or what happens when some devices go off the network. While we're on the topic of challenges, let's talk about one of the most important ones for this specific project, the skill challenge. For this project, we will be using Java and the Android SDK for development, yet we will be dabbling into a few other unfamiliar areas. One of the main new concepts is direct Wi-Fi. Direct Wi-Fi is making more and more innovative ideas come to life, and we are looking forward to this idea becoming one of them. The greatest advantage of direct Wi-Fi is no dependence on an ISP backbone, considering the greater probability of someone having a smartphone around you. Major mobile operating systems such as Android and iOS provide support for direct Wi-Fi and make available APIs for building peer-to-peer apps. Applications such as FireChat and Superbeam, which are popular today, use direct Wi-Fi as a medium for information exchange. In addition to the knowledge and experience that will be gained in the area of direct Wi-Fi, we also plan to incorporate test-driven development. This software engineering practice is often used in today's software industry and has the ability to drastically increase the quality of code. In this practice, software is built through the repetition of a very short development cycle. First, the developer writes an initially failing test that defines a desired functionality, then produces the minimum amount of code to pass that test, and finally refactors the new code to acceptable standards. This will be a new skill for all of us, and the experience within this area can be applied to projects and other undertakings in the future. So, not sure if you've noticed, but Mr. Black in the bottom left corner had been looking for his friend Miss Pink since the beginning of this presentation. But thanks to Meet Me Now, they have now been reunited. So, with that being said, we're looking forward to the opportunity to bring people together one send at a time.